So the link is here. All right. So then now I think if you click on that, now the only thing, so I just sent it in a text. Now if you're working on just a phone, the thing with that, there might be like a delay.
Okay.
So it's like, if we're talking on the phone, I think now when I did the test, it was like a 10 or 20 second delay. So it's like if we're talking on the phone, maybe 10 or 20 seconds later, it'll show up on this link.
Okay.
So what the idea that I was going to do is that like we can kind of have like a quick dialogue, and then you can like just basically take a picture of whatever your question is and send it to me, and I'll pull it up, and then you can ask your question. We can kind of talk about it, and then you can kind of like turn it over to me and like watch the explanation. And also have to let you know that all of this is like being recorded, and I can delete stuff later and all that.
Okay, so I'll be able to talk.
Yeah.
Okay.
But yeah, that's the idea. So again, like I said, this is my first time trying this. So, and I'm actually like, the reason I went on the call because I'm sitting in a parking lot on the north side of town. I'm sitting in the car, so I'm like doing like battery power. I got some chargers or whatever, but so I was like, well, let me go ahead and call while my batteries are kind of at max before things start to run out.
Okay.
Yeah, and it should be fine. I mean, I was sitting like in a coffee shop, but when I tested it out, the person was telling me there was a lot of background noise and they couldn't hear me. So I was like, okay, let me set up shop inside the car where it's quiet. I can control the volume, all of this kind of stuff.
Okay.
So yeah. So a few questions. So let me tell you a little about myself. My name is I go on YouTube. I go by Beautiful Mind. My students know me as Mr. Pfeiffer, and I'm just a math teacher, and I'm just kind of playing around with some of the technology and equipment. And I've just been teaching like at the collegiate level since about 2009 when I was in school, and that's all. So I'm just kind of getting out there. What could you tell me a little bit about the student?
I'm sorry, you can tell you a little bit about myself?
The student.
The student?
Mm-hmm.
For me? Myself?
Yes.
Oh, okay.
I guess I thought Hollis was a guy's name. I didn't realize it was a woman's name.
No, it's me. That's my first name.
I'm sorry.
Yeah, it's me. It's
okay.
Me.
Okay.
I get that a lot. Last name, whatever. I'm actually trying to get in nursing school.
In which school?
Nursing.
Nursing. Okay.
Program.
Okay.
So we have to take this test called TEAS test.
Okay.
And the test is subdivided in 4 parts: your grammar, English, reading, science, and math. So I took it before.
Okay.
I didn't do good math. It's my lowest academic point for me. So in order to pass, I have to bring my math up to get into the program.
Okay.
So it's very imperative that I pass the term. I've gotten tutored, I haven't tutored before off the website, but she was mostly helping me with math and science. And I got science now, but it's just math I can't grasp it like I need to. I don't know what formula go with what.
Okay.
When do you add? When you multiply? When because it flips over.
Right.
And it just confuses me. Even in high school, I did horrible.
Okay.
So just basic algebra and that's pretty much it. I mean, if I can just boost this math and get to where I can comprehend and know the formulas and
okay.
do the work, I should be fine.
Okay. What's your like when do you take the test again? What's your time frame looking like?
I registered to take the test on the 19th of next month.
So that's like just about a month out?
It is.
Okay.
I've been studying since last year.
Okay.
Trying to grasp it on my own. I mean,
did they like kind of give you any study materials or things you can look at?
Yes, I have the actual manual. Those questions
that
I was sending you come from the study manual from the teacher.
Oh, okay. And how did those pre-recorded videos work out for you? Were they good or was it okay?
Yes, they were excellent.
Okay.
I just don't know. I hear you saying, the inverse, the undo, certain one, but I feel,
I feel you. I feel you. Yeah. So okay. So I mean, this session will be similar, but it is different because we're live, so you can kind of ask questions as we go. Now, one thing also I would like to, when I was making those videos, I realized something else that we could do. Now I can answer a lot of the questions, but the real learning or the real information exchange comes when you're doing the work. So it's like if you can what might be a good idea is take a picture of the question and then attempt it on your own and show your work. And like if you just like write it out and just snap a picture of the work that you did and send me both of those pieces, then I can edit the picture that you send me and give you comments, and I can say, okay, this is good. I can see clearly what you're doing here. Okay, this is what I would have done different. But that's what I know is needed. I need to really be checking your work as opposed to answering the questions for you. I know that's part of it. Like if you're completely lost, then we can like walk through something. But the idea is that you want to try to do as much on your own as you can, and then hey, this is where I got stuck, and we can try that. Do you have you wouldn't happen to have some work already ready that you've like working on?
Yeah, I have notebook full of ways I'm doing it on my own.
Okay.
I've been at this for a minute now.
Okay. So since we're early, you can just snap a picture and just text it to me, and then I'll pull it up, and you'll see it should pop up on the YouTube. It seems to be good health, and it seems to be good to go. So if you just like send me a picture, and then I'll pull it up, and when you see it on the screen, you can kind of walk me through it, and like whatever you see and don't see. Yeah.
Okay.
Yeah, and so while you're getting that together, that's the reason why I was like, I'm doing all this stuff for free, because I'm really just playing around and trying to take advantage of a little bit of time that I do have and seeing the capability of these machines. I've been looking for something like this for a long time, and I've just figured it out. I was like, oh, I could try it on YouTube. So.
Okay.
So yeah.
Okay.
Yeah.
Okay, yeah, because I'm not very computer savvy, so I didn't know about the how we go in person.
I mean, yeah, if you're on the phone and you got my live video up on YouTube, that's pretty good. I just asked I got to get the other video off of YouTube. You listen to my sister, like I was going back and forth with it, and she was like, I don't know how to pull up a YouTube video. I was like, what? You don't know how to pull up a YouTube video? But yeah.
I was like, I don't know, and I said, well, he's in the West End. I'm from that side of town, born and raised. So I'm like, okay, well, you can be.
Yeah.
Yeah,
I'm in the area. But
okay, I'm gonna do whatever I need to do. What I need to do.
Mm-hmm.
So, yeah. So that's about it. But I can show some work and snap a picture.
And then the other thing about like my teaching technique, basically I kind of like, I mean, I'm not really good at like general stuff. It's like if you just kind of give me specific questions, and then we'll kind of go from there. So it's like, just send me pictures of whatever, and then that's just going to be a starting point, and then we'll kind of probe around from there. That's usually how that goes for me.
Okay.
So like, just wherever you want to start, you send it, and we'll take as much time as we can.
Okay. So take the pictures of the work that I've already tried to do on my own.
Like first the original question, just the entire original question, and then whatever work you'd like me to look at, and then we'll go from there.
Okay. I'll like into that now.
Okay.
Okay. So we'll just come back on at 2 o'clock?
No. Now it's fine. Yeah, I just started early because I don't know what my battery situation is going to be like. So yeah, now it's fine. Just send me pictures and we'll get it started. Like I'll just.
Okay.
Yeah.
Okay, so I just go back on YouTube.
Yeah. Maybe send me a few pictures first, and I don't know that you have to get off the phone. I'm not like. If you do,
Yeah,
if you,
I had to get off of YouTube
oh, I see.
when you called.
I see.
So,
So yeah, I mean, we can stop the phone conversation. That'll be fine. But yeah, if you send me pictures and just either in a text or email or any of those ways, and then because the stream is still going, so it's like I'll just pull the questions up and we'll go from there. Then you can always text, and there's a live chat on YouTube. You can still be live with any of those techniques as well. And then
oh, okay.
and then if you want the audio, just call me back and we'll get the audio going. Yeah.
Oh, okay. So the audio will not be playing while we on
Yeah,
YouTube?
yeah. I think if you get on YouTube while on the phone, I don't know what happens. I don't think I've ever tried that, but you can try it.
Okay.
Yeah. So
Okay.
yeah.
Okay. So I snapped you a couple of pictures via text.
Okay. Okay.
Okay.
Yep.
All right. Thank you.
My pleasure. If I... Okay, so we should still be live via YouTube. So it looks like my making a lot of noise. I'm getting like red. Is it this? Oh, it is this. Okay. So I am just waiting for some questions. I didn't realize Miss Hollis was a woman. Hollis, I thought it was a man's name. I'm sorry, Miss Hollis. But yeah, so I just kind of try to fill the dead air. So if it's algebra, so the thing with algebra is essentially just like arithmetic, just adding, subtracting, multiplying, and dividing. And I'll back up once I see that people are on and things of that nature. But algebra, all it is really just arithmetic, but you just have an unknown. And so in mathematics, when we have something that's unknown, we just give it a name, and then we still use the regular rules that we're used to using. There are some interesting things that come out of it when we do algebra, but So yeah, I don't. Now I know there are other things, other techniques. I'm just kind of blabbering until until a question comes through. But as far as like the live stream, I think this is. How do I change the volume? Because it seems like it's kind of loud. Okay. As far as the live stream, it's still loud. I don't know what to do with that. This. Okay, that seems better. All right. So as far as the live stream, I know there are other techniques like as far as like Zoom and things of that nature, but it would be nice if YouTube had a way of capturing the audio as we do this. So let's just sit tight until we get our question. So again, right now, for anybody that is watching and that does get access to this account, you can just send me questions, and I'll take time to. Usually, I do like dedicated pre-recorded videos. I'm trying my hand at trying live. I'm trying this live thing. It's a journey. It's a lot of fun. So, Miss Hollis, I'm not sure if you are there or not. If you are there, if you can hear this, there is a live chat. Could you either text me a response saying, yeah, you got it, or in the live chat window, you can type something there as well, if you can hear this message, so that I know that things are working properly. But if not, it's okay. Maybe I gave it. Ah, there we go. There we go. All right. So I just received her question. So again, Miss Hollis, if you can hear me, um, so on the YouTube channel, there's like a live chat somewhere, like either on the bottom or the right. Um, in that window, if you could just like type something so that I know that you can hear me. But I will load your question and we'll get started. Let me see. So I can go like this, right? Okay. All right. Hopefully, I got like a little studio set up here. This is kind of dope. Come on, if it works. Personal hotspot. Okay, let's just cancel. I don't want to do that. How can I pull that up? Oh, I can pull it up here. Okay. All right. Just about ready. Sorry about that. Go away. So communicate. All right, there we go. Your location. There we go. All right. All right. Let's bring this back. All right. So okay. So we have Beautiful Mind Hollis. So. Thank you, Miss Hollis, for indulging me, just giving us a go. Let me see. Let me do this real quick. Can you hear? Can you hear my audio? Okay. Now let's look at this. Okay, so I see that one. All right, so we'll try to take these one by one. Okay, let's start there. So we'll look at this first. Okay. So now there aren't really any instructions, but I just see some notes. So the first thing we see is this 1/1000, right? So if you divide something by 1,000, like if you divide by any power of 10, if you're dividing by like a large number, then the whole thing is going to get smaller. So if we say 1 divided by 1,000, what's going to happen is the decimal is going to be, let me see, say I have a 1 right here. The decimal is here. If I divide by 1,000, that means this number is getting smaller. So the decimal is going to move to the left 3 times, right? So since there's 3 zeros, I'm going to say 1, 2, 3. My decimal is going to move here, and I get 2 zeros. That's where this comes from. Okay. So, if you have like, I don't know, 500 slices of pizza and you got to divide it amongst 1,000 people, then everybody gets like half a slice of pizza. So you move the decimal to the left 3 times. Again, if you said 500 divided by 1,000, right? Again, it's going to be 500. The decimal's here, and you move to the left 3 times. So you go 1, 2, 3. So you have 0.5. It's going to be 0.5. So that means that everybody will get half a slice of pizza. That's just a quick little something. Um, but yeah, with the powers of 10, so if you divide by like 1,000 or 10,000 or however many zeros this are, that's how many times you're going to move the decimal. Okay. Um, that's just kind of piggybacking off of that. Okay. Now let's see what else we got. So then if we had 0.25, if we wanted to write that as a fraction, for instance, right? So if we had 0.25, so this is the tens place, this is like tens, and this is the hundreds. So since we have two numbers behind the decimal, we're gonna divide by 1 with 2 zeros. So this is gonna be, okay, cool. So I got your text message. So if you can hear me, try typing something in the live chat window and see what happens. So there's a live chat. If you could find it on YouTube, you can type it in. That way, you can kind of type your questions as they come to your mind, and we'll have a login. But if we wanted to write 0.25, say as a fraction, right? So we would say 25 over 1. Now, since we have 2 numbers behind the decimal, we're going to have 2 zeros, like that. Okay. So then, if you were writing this as a fraction, both of these are divisible by 25. So you could say 25 divided by 25, and you could say 100 divided by 25. All right. So then 25 divided by 25 will be 1. 100 divided by 25 is 4. Okay. So now, if ever something's not clear, just stop me, get my attention, send a message, type in the chat, text message, any of these ways. Just get my attention and ask me to stop, type your question, and we'll try to change the pace or change the angle or the topic. But otherwise, I'm just going to kind of speak on what I have. So 25 over 100 would be 1 by 4. Okay. Let's see. So some more information. So that's just writing these as fractions. So then some more information. So let's do this. So some background information as far as decimals and fractions. Okay, so let's say fractions. Say we're doing fractions because I'm not 100% sure what they're asking for, but so fractions are any 2 real numbers that you can write as one real number or one integer over another. Not real numbers, but one integer over another, as long as the denominator is not 0. So when I say integers, I'm talking about numbers like 0, 1, 2, 3, 4, -1, -2, -3, -4, all of this kind of stuff, on and on in both directions. Again, so fractions, you just have a counting number over another counting number, and the bottom can't be 0. So then decimals. So decimals that terminate, like all of these are examples of, these are actually fractions, because 0.25, because it stops, it doesn't keep going, we can write it as a fraction. You're just going to put 25 over 100 and then simplify. 0.4, again, because it cuts off. So then if we want to write 0.4 as a fraction, that's the same as, again, you do your 4 over 1. Since there's only one digit behind the decimal, it gets 1 0. So you would do 4 over 10. And then to simplify, let me offer another way to simplify this stuff from what I offered before. Okay. So now, if we had 4 over 10, now 4 is what times what? 4 is 2 times 2, right? 10 is what times what? 2 times 5, right? Notice everything is multiplication and division, so we can cancel. You have 2 divided by 2, and this leaves us with 2 over 5. Now we could have done the same thing for the 25. 25 is what times what? 25 is 5 times 5. 100, I think, is 10 times 10, and then 10 is, so this is 2 times 2 times 5 times 5, right? So then the 5's cancel, the 5's cancel. So then here we will have 1 over 4, like we had before. Ooh, my laptop is getting low. Can I? Is it gonna? Shouldn't mess things up. Let me try it. I guess I need to be home when I'm doing this stuff, so that I can have everything that I need. Ooh. But that's how it goes. Where is it? Oh, here it is. Okay. Try to give it some power. All right. Got a little bit of power there, and let me see if I can redirect this power. It's kind of acting up on me before. Oh, God is good. All right. We are in business. So, again, if ever anything is too fast or too much, just give me kind of an update. Just type something in the chat to kind of get my attention and let me know if I need to do something different or if I'm on the right track or on the wrong track. Now, with this point 1111, that typically, now if it cut off at the 4, then you would do the 1111 over 10,000. But, typically something like this, it'll go on and on. So we'll have something like 0.1 bar. Now, repeating decimals, those can be written as fractions too. Now, I don't know if they want you to be able to write repeating decimals as fractions. We do have a technique for writing repeating decimals as fractions. I'm going to save that for another time. If that's something that you think you'll need, just let me know and we can go further in detail on that. If not, I'll just kind of make a statement that, repeating decimals can be written as fractions. Now, you can do a quick YouTube search, and they're basically going to tell you the same thing I would tell you. But I don't. It can be kind of a bit much. So it's like, if you do want to see that how to write that as a fraction, we can go through it. But you'd have to message me and let me know. Okay. So then the next part, we have 0.2323. So it looks like the 23 is repeating. So this would be the same as 0.23 bar. Okay. Let's go ahead and do one and show how we can write it as a fraction. So just kind of brace yourself. It's a little bit of algebra. It's a little fun, but when you get it, it's just fun. Just try to, have fun. So now with something like this, if I had a 0.23 bar and I'm trying to write it as a fraction, okay? So the technique I've seen, first we would set this equal to x, right? Now since I have, what you want to do is multiply by a power of 10 so that, the repeating part stays the same. So if I for instance, if I multiply by 10, then the repeating part is going to be different. So I'd have to multiply by 100. So then if I multiply this by 100, I'll have 23.23 bar equals 100x. So what I did there, I multiplied the left by 100 and the right by 100. So in mathematics, this is Miss Hollis. Hi, Charles. What about the number lines, like the X and the Y? Okay. X and Y number lines. Okay, we'll come into that. Let me see. Was that in any of the pictures? Okay, so if you have a question about the number lines, if you can find an example and pull it up, then we can use that as a jump off point. So if you have a question about the Cartesian plane or the coordinate axis, maybe I should move that to the right. Move this over. I guess it'll be fine for now. I gotta fix that somehow. I think I'm gonna just remove that. Yeah, so if you have let's move that down. So yeah, just you would have to find an example of it, and then that's how we would kind of go about that. That's usually called the coordinate axis, where you have the x-axis and the y-axis. The x-axis tends to run side to side, not tends to, but runs side to side. The y-axis runs up and down. But yeah, the best thing with something like that is just bring it up an example, and we'll kind of work through it. So for this, if we wanted to, so then what we want to do, I'm going to kind of rearrange this a bit. So we have 100x equals 23.2323. Keep in mind that keeps repeating. And then the other one we had was x equals 0.2323, and so on and so on. So now the technique that we're going to use, if we wanted to write this as a fraction, we're going to say the first line minus the second line. So we're going to subtract that, and we're going to subtract this. All right? Okay, my power seems okay. Okay, I see. You're going to find one. Cool. This is actually working. This is pretty interesting. All right, well, let's keep it going. All right, I'm getting excited. You have to forgive me. All right, so if we keep going, so then 100 minus 1 gives us 99x, right? Now, if you subtracted this, the decimal parts, like all of this stuff here in orange, it's all the same. So when you subtract it, it all goes to 0. So if you say that top minus the bottom, all you're left with is 23, right? So then x is going to be, so then if we were getting the x by itself, now if we have 99 times x equals 23, and we want to move that 99 to the other, since we're multiplying, the opposite of multiplication is division. So then we would divide both sides by 99. In algebra, we have a thing called the multiplicative property of equality. In other words, you can multiply or divide the same thing on the left and right side of the equal sign and preserve equality as long as it's not 0. So you can multiply any real number other than 0 on the left and right and preserve equality. So I multiply by 1 over 99. So something divided by itself, and I know some of that sounds circular because I'm saying I'm multiplying, but I'm really dividing. There's another thing that when you multiply by a fraction, that's the same as dividing by that number. So that's what I'm doing there. Like if I multiply by a half, that's actually the same as dividing by 2. So when I divide by 99, that's the same as multiplying by 1 over 99. All right. So then on the left, so something divided by itself is 1. So then 1 times x is just x. Okay. So then, and then 23 over 99, that doesn't simplify. So that's actually what the fraction. So the original, the 0.23 bar as a fraction, I would say is 23 over 99. Okay. Now to check something like that, I'm gonna put it in my calculator. So let me pull up the calculator, right? And I can change that. How do I? Let's go here. No, not like that. Like this. Yeah. No, that's not the right one. There we go. That's good. And sorry, I'm doing some stuff on the fly, which is fine. All right. So let's try this calculator out. So I want to see. So one of the things that made me fall in love with mathematics, is that the fact that once I kind of got a sense of what was going on, I could check my work. So something like this. Say we're saying that this is that original thing, that 0.23 bar. We're saying that written as a fraction was what, 23 over 99. So we're saying that this is 23 over 99, right? Now, if we're saying that's the answer, what does that mean? Oh, we got another one. Okay, I'm gonna pull it up in just a second. Okay, so if 23 over 99 was the answer, what does that mean? That means that, if you say 23 divided by 99, we should get that 0.23 repeating. So in my calculator, if I said 23 over 99, enter, see, we get the 23 repeating. Okay. So, that whole thing on converting repeating decimals to fractions, I mean, it's interesting. It's on YouTube. You just got a live recording of it. I'm going to pull up, I did get your question. I'm going to pull it up now. We didn't make it through everything on the page, but we can. We got time. I'm not going to be going anywhere for a few hours, so I'm good to go. I don't know what your time is like, but. So let's go back. So we confirmed that it worked. So let's pull up the question you just asked. So I'll go here like that. My battery's looking good across the board. Oh, I see. And we got more. This is awesome. Oh wow, you got some good stuff. You can tell I really am a nerd. All right. Let's start with this one actually. So I'm gonna pull this up. This. And I want to put this back. Come on. There you go. Cool beans. Okay. So let's look at this. Is the whole question there? Traditionally shown as a Cartesian plane. Okay. Let me see. Because it looks like the whole thing is in there. Okay, so this is just... Okay, I see. Kind of like a background. Okay, I'll just kind of do a quick dialogue on this, just like an overview. And I'll go like this. So we'll just kind of take a look at this. All right. Traditionally, it's shown as a Cartesian plane. So what this is like typically the XY plane, right? XY coordinate axis. Now usually here is your positive x-axis. So going to the right usually is positive x, and usually like when you get questions, they'll label it. So it's usually, like 1, 2, 3, 4, 5. And it might be different. It's just, and the other way is going to be negative, -1, -2, -3, -4, so on and so on. It depends on how it's labeled. And then, so if x usually runs side to side with this is called the Cartesian plane or the coordinate axis, which is this right here. So the Cartesian, let me not do that. Nope, that's too small. Cartesian plane or the coordinate axis is another way. Axes. But usually the positive x runs in that direction. Alright. Yeah, this is fine. And then the positive y runs in this direction. So this is the positive y. You might have 1, 2, 3, 4, 5, 6, and then -1, -2, -3, -4, so on and so on. And then the center is called the origin. It usually has a coordinate 0, 0. So every point on this plane is called the ordered pair. So it takes on the form x, comma y. All right. But the first number tells you which way to remove as far as x is concerned, and the second number tells you about the y. If the first number is positive, you're going to go right. If the first number is negative, you're going to go left. Then if the second number is positive, you go up. Second number is negative, you go down. For instance, let's look at A. So A, based on the way I numbered it, it would be like over 3.5 and up 3. You could say, so like A, for instance, A is approximately, because it's not exact. It's the number 3.5, comma, and then it went up 3.5. So what it's saying is that we go right 3.5, which puts us here. So let's do A in this color. So if we go right 3.5, starting at the origin, and then we go right 3.5, so we're here, and then we go up 3.5, so there's 1, 2, 3.5 puts us there. Okay, so that's how we basically read the coordinate plane. So every ordered pair, so this one we might say is 3.5, comma 3.5. Okay. So then, like for instance, G for instance might be -2 and then 6. So G might be something like -2, comma 6. Where on the x-axis, if we started at the origin, we went left 2 and then up 6. D, for instance, might be -4.5, comma 0. -4.5, comma 0. Okay? And you know, they all kind of continue with that. So in that kind of notion. And so what that means is, since the first number is negative, that means we go left 4.5. And then since the second number is 0, we don't go up or down or anything. We just kind of stay where we are. So we just went left 4.5 and then we stopped. Okay. So basically, again, these are called ordered pairs, where they take on the form x comma y, like that purple x comma y you see in the upper right hand corner. Okay, cool. The time is good. Okay. But yeah, that's how the Cartesian plane goes. I think we had another question. Let me pull that one up. So that's just a brief overview on that system. No. Yeah, here. Let's do this one now. So let's see what's going on here. Okay, so this is like a recap on slope. Okay. All right. Now there's a whole. I try to take as many notes as I can. So usually when we're talking about slope, the discussion here is usually centered around what I call lines. All right. So then, now, whenever I'm dealing with lines, okay. So now we're gonna kind of get into like our geometry and our pictures in our mind. So this for me, this kind of piqued my interest because I remember in geometry, you know, like the reason I like geometry is because of just the pictures. I kind of consider myself an artist a little bit. I might not be the world's greatest, but you know, I'm a little artsy. So it's like I have an appreciation for creation, and you know, things of this nature. And so the topic of like lines made a lot of sense to me, and like dimensions. And so what I mean is like, okay, so a line we would consider that like the first dimension. So like the 0 dimension like might be a point. And then if you ever want a straight line, what's the least amount of points that you would need to make a straight line, right? Because if you have 1 point, you know, there's so many different things that can happen, different paths that can cross it. But if I'm like, say I'm here and I'm trying to go where I want to go, Fiji. Let's go to Fiji. So between here and Fiji, a straight line, you know, if I wanted to take the shortest distance, I would need a straight line. So in order to make a line, you need at least 2 points. See what I'm saying? So that's why in this graph, you see they have the point on the left that's called 0, comma b, you know, where they went left and right 0, and then they went up b units, just some positive distance. And then, you know, they took that second point over to the right. But notice there are 2 points. So to make a straight line, you need at least 2 points. We would consider that the first dimension. Then, you know, so then the Cartesian plane is an example of something that's 2-dimensional or 2D. You take a line, and then, so if you have 2 points, then you can maybe take a second line and make it cross the first line at 90 degrees at a perpendicular. So when I say 90 degrees, that's an angle, and that angle is like, you know, the corner of a book, the corner in the wall. If you look at your ID, the corner of the ID, that's 90 degrees. In this picture, the 90 degrees is here, where I draw the purple box. So the Cartesian plane, if you look at the x-axis, that's a line. The y-axis is a second line, and then we put them at 90 degrees to each other. So now we have a system for a flat surface. So it goes on forever, it's flat, and it goes on like that. Then you can look at 3D. 3D, you just take a third line, or the third dimension, and then you would put it perpendicular to those first two. So then you would be coming off the page into like, you know, going up and down. So then, you know, that's the basis for dimensional talk. You know, then you can actually go beyond that, but that's a whole nother discussion. But these ideas and all the concepts and the pictures and the way it kind of explains our experience is what made me fall in love with mathematics. Like, because it's so, you know, you can describe anything that we see in this sense. And then that's where you get virtual reality and the phones and, you know, the apps that we play and our positioning system and everything that we do in this reality. It always kind of boggles my mind when people say, oh, I don't like math or don't do it. I was like, yeah, you do. You use it all the time and you just don't realize it. Like, everything we do is mathematical. It's just that, you know, A lot of people don't really know that they're using it, but everybody uses it. You know, you just don't know that you're using it. Anyway, that's just me rambling and talking and, you know, falling in love all over again. So back to lines. So now when we're talking about lines, you need at least 2 points, right? And then whenever I'm looking like thinking about formulas, there's only 3 formulas, and it's really only 2, but there are 3 formulas that I always have ready to go whenever I'm looking at lines, okay? So then the first formula, I would say, it's called the point slope form. So you have the point slope formula, okay? Now I'm kind of chatting, I'm just talking because I'm under the impression that this stuff is being recorded, you know, we can splice it and all that kind of stuff, and we should have a copy of it, you know, but yeah, so if we're doing the point slope formula, let me get back to my video, okay, and the way that formula goes, you have y minus y1 equals m times x minus x1, right? And so this formula, you use it whenever you're given 1 point and you're given the slope. So like for instance, say b, I don't know, b was 4 in this example up here. So say this was the point 0, 4, right? And then, so this would be our x1 and our y1, right? And if we're given the slope, some negative number, I don't know, we'll say the slope is down 2 and right 4. We'll say the slope is negative 2/3. Or, yeah, that's fine. It'll work. Basically, where we go down and then to the right. So when you're given a point and a slope, we will use the point slope formula. You will plot that first point, or you can use that point and use the slope to find the equation of the line through the 2 points, right? And we'll come back and do an example on that. Let's just kind of finish developing the idea. So that's point slope formula. And then the second one that tends to come out is the slope formula. So you use this, it's like, say you're given 2 points and you weren't given the slope, you need to find the slope. So in order to find the slope, one of the ways you're going to say y2 minus y1 over x2 minus x1. Okay? And then the third formula that tends to come out is going to be the slope-intercept formula. Okay? And that's your classic y equals mx plus b, where your b is your y-intercept and your m is the slope. Let me kind of shrink this down so it fit properly. Okay, so hopefully I didn't ramble too terribly much. And, you know, now again, stop me if you ever have any questions, just type it in the chat. I'm going to have to clear that chat or something. Just kind of getting in the way. Yeah, I don't like it. It's in the way. I just hide it for right now. Okay, so whenever I do lines, those are the 3 I have that I try to have ready to go. 1, 2, and 3. So now again, this I think this will make a little more sense if we had a specific example, but that's just kind of an overview. And so it's like I mean, there's more, but again, that'll get more clear with you just have to really work examples. You really just have to work examples. Now I could go back to what you sent earlier. Now there was another question here. Let me pull up this next one. So there's this. All right, cool. All right. So let's look at some examples. Now it says, number 1, in which of the following sets of terms are all 3 values equal? Okay, so we want to compare all of these numbers to each other. So we want to see, you know, are they equal or not? Okay. So let me, I want to copy this. Can I copy? I want to paste. Okay. I guess I could turn this back on. All right. So now let's look at 1A. All right. So I guess it might be easier to turn the others into percents instead of turning the percents into fractions. Yeah, I think it would be easier to compare if we put them all into decimals. So, I guess whenever you hear this question, just let me know. Are you able to use a calculator or not? Right now I'm gonna assume that you are able to. If you're not, then I'm gonna have to come back and do this a little differently. Okay. But if you are able to use a calculator, so I'm just gonna use the calculator here. Okay. So if I say 1 divided by 8, we'll get this 0.25. Okay. So then the first one, so 1 over 8 is the same as 0.125. Then the second one is already 0.125, so that's promising. Let's look at the third one. Now we have 12.5%, so let's analyze that. So if we have this 12.5%, oh, it's close enough. Is that a yes? You're able to use a calculator? I think that's what that's about. But the percent symbol, let me do it like this. So if you had 12.5%, so the percent symbol, you can look at it as 1 over 100, right? And this is still 12.5. So you can look at this as 12.5 times 1 over 100. So then what you could do is 12.5 divided by 100. So the percent symbol, typically you can do, it means per 100. So now if we divide by 100, that means the number on top, is it getting bigger or is it getting smaller? It should be getting smaller. So that means the decimal is going to move to the left twice. So that means this is the same as 0.125. Okay? So 12.5% is the same as 0.125. So that last one is 0.125. So it looks like the first one, they're all the same because they all are the same as 0.125. Okay, so I would say A is good to go. But let's just, for the sake of discussion, let's just look at the others. Now, let's do the first one by hand. So if we have a third, for instance, 1 divided by 3. Now if we're going to do this, the 1 falls to the right, so we would say 3 divided into 1. Now if we're doing division, the decimal is here, and you need a 0. Now how many 3's are in 10? Because the 1 was too small, right? So how many 3's are in 10? Well, there are 3. 3 times 3 is 9. 10 minus 9 is 1. You add a 0 and bring it down. How many 3's are in 10? It's 3, and it's going to be the same thing. So it'll just keep going. So since it'll be the same thing over and over and over, we do a 0.3 bar. Okay? So a third, as a decimal, we can say is 0.3 bar. Notice this middle part is 0.3 bar. So we have 0.3 bar. We have 0.3 bar. Now is, because percent. Okay, I see. So we need to look at 3.333 bar percent. Now we just said the percent symbol means per 100, so we would say 3.333. The percent symbol means 1 over 100, right? So what this really means is 3.333 bar divided by 100. Now, if we divide by 100, that means the decimal is going to move to the left twice. It's going to get smaller. So if we move it left twice, we get 0.03, and then the 3's keep repeating. But notice this is not the same. Okay? So this one I would say is a no-go because of this one. Now, if that had been 33.3 bar percent, if that had been 33 instead of a 3, then I think it would have worked. But the percent symbol means per 100, so we get the 0.03 bar and not 0.3 bar. Okay? And again, when we're done with this session, it should come up on YouTube. I did a quick little test run before we started, and I still got to take that off of YouTube. I'll take it down. It'll take a hot second. But I was trying to be punctual. Yeah, it took a little bit to kind of get set up here, but it's still fun. So we would say B is a no-go. Let's try C. So I'll do 1C. I'll just keep going down. So then if we have 1C, all right? 1C is, we got 12 over 5, so let's do that first. So let's look at 12 over 5. So then what this becomes, the 12 falls to the right. You say 5 divided into 12. Divisor and dividend. The 12 is called your dividend, and the 5 is called your divisor. Nothing important. It's just, that's what they call it. Okay. So my battery is actually doing pretty well, but it's not going to last forever. So, when it starts getting kind of low or something kind of conks out, then we'll stop there. But it's actually still doing pretty well. So now if we're going to divide 5 into 12, notice the decimal is here behind the 12. So the answer in your quotient or your answer goes above it. Now, notice the 1 is too small for the 5, so we need to move over a space. How many 5s are in 12? Well, there are 2, because 5 times 2 is 10. So then we subtract, we get a remainder of 2. We add a 0, and we bring it down. How many 5s are in 20? Well, that's 4, because 5 times 4 is 20, and there's a 0 remainder. So 12 over 5 written as a decimal is 2.4. So that first one there is 2.4. But then the next decimal is 0.24. 0.24. And if you don't believe me on the fraction, which you shouldn't, you always want to question and confirm. Don't take my word on it because I am human. I make mistakes. Let's look at the calculator. So let's do 12 divided by 5. We should get 2.4. 2.4. Okay? So again, don't take my word on it. I'm a human being, so I do make mistakes. The last one is 240%. Let's look at 240%. Now remember, the percent symbol means per 100, right? So what you can do here is you can say the 240 divided by 100. If you divide by 100, the decimal is here. We move it left twice. So if we go left twice, then we get 2.4. Sorry, it's not a 4. So the last one is 2.4. So the culprit in part C was the middle one. So the culprit here is this guy, and we'll say no. The other two are the same. Okay. We don't have the luxury of checking everything in the calculator whenever possible. We don't always have the luxury of checking every last part in mathematics, but when it is possible, you definitely want to take advantage of it. He who checks the most, I don't know, earns the most, whatever. Earn those checks. So earn the checks by checking your checks. Anyway, whatever. But the whole point of the matter is, you want to check whenever possible. Like something like this, suppose we interpreted the percent symbol wrong, then, it's nothing to really, we would be checking the wrong thing. But, whenever we can, we try to check to maximize our score. So to maximize your checks, you got to maximize your checking. Anyway, I'm just trying to think of some catchy way. Let's look at D. We got 7 over 1,000. Okay. All right, so then 1D, we got 7 over 1,000, all right? So if you're dividing by a power of 10, all all you're doing is moving it to the left 4 times because you're dividing by a big number. So this is just going to be 7. The decimal's here, but you move it. When you divide by 1,000, it's going to make it smaller. So you're going to move it to the left 3 times because there are 3 zeros. So you go 1, 2, 3 right there. So now the result is 0.007. So 7 divided by 1,000 is 0.007. Okay. Let's look at the next one is 0.7, which is not the same. And then the third one is 0.7%. Okay. So for 0.7%, again, the percent symbol just means per 100. 0.7 per 100. So you're going to say the 0.7 divided by 100. That means you're going to move the decimal left twice, and you're going to hit 0.1227. So again, in this one, the first and the last were the same, but the middle one was different. So here, this one is different. So the only one that where they were all the same was the first one. Okay. Let's see what else we got. Oh, that was just the first one. Okay, so hopefully I'm not going too fast. Again, you should be able to rewind and come back to any video. I think you can rewind right now as well. Let's look at, so that was number 1. It says, which of the following is the correct way to simplify something expression to a fraction in lowest terms? Okay, so let me copy this. I'll bring up a new page. Cool. Okay, I want to paste. Now look. I want to edit, and I want to get rid of number 1, and I want to keep number 2. All right. All right, Ms. Hollis, are you still there? You know, if you are, just comment in the chat so I know that you're still there. All right, so if we're looking at this number 2, so we have a half plus 2/3 plus 3/4. It says, which of the following is the correct way to simplify this expression to a fraction in lowest terms? Okay, so what I'm going to do is just do it the way I would naturally do it, and then we'll come back and compare it to the answer. So what I'm going to do is bring out some paper. Yeah, that should be fine. Okay, so if I said 1/2 plus 2/3 plus 3/4, right? Now, if I was going to add something like this, we need a common denominator. Now, I guess if you're doing it with a calculator, you could just put this in the calculator. Yeah, because I'm pretty sure you'll. If you let me do it by hand, and then I think if you can use a calculator, something like this, you're probably better off just doing it in a calculator. But it opens up a whole range of discussions. So like here, we got to do something called find the least common denominator. So one of the techniques, since we have a 2, a 3, and a 4, we have 2, 3, and 4. We're trying to find the LCD between those. One technique, when it's all numbers like this, you can take the largest number, in this case it's going to be 4, and then kind of go through this little procedure. So you can ask yourself, is 4 a multiple of 2? You would say yeah, because 2 times 2 is 4. Is 4 a multiple of 3? You would say no. So then you would take the largest number and double it. So now you get 8. Now you ask yourself, is 8 a multiple of 2? Yeah. Is 8 a multiple of 3? No, because it doesn't divide evenly. So then now you triple it. So you multiply it by 3. 4 times 3 is 12. So then you say, is 12 a multiple of 2? Yes. Is 12 a multiple of 3? Yes. Is 12 a multiple of 4? Yes. So then 12 is going to be our LCD. So that's just one technique. So we're going to rewrite all the denominators to become a 12. So this is going to be 12. This is going to be 12, and this is going to be 12, right? So now, 12 is going to be a multiple of all of those denominators. Then we ask ourselves, okay, what do we multiply 6 by in order to get, sorry, what do we multiply 2 by in order to get 12? The answer is 6. But what we're going to do, we're going to actually multiply by 1 in a form that gets it to what we need. So I'm going to multiply by the first one by 1 in the form of 6 over 6. Right? Because something divided by itself is 1. Now when we do this, to multiply fractions, you just multiply straight across. So the top with the top and the bottom with the bottom. So that means this new top is going to be a 6. 6 times 2 is 12. 6 times 1 is 6. So then, what do we multiply 3 by to get 12? Well, we multiply 3 by 4. So now we're going to multiply this fraction by 4 over 4. Okay? So then 4 times 2 is 8. 4 times 3 is 12. Okay? Now, what are we multiplying the 4 by to get 12? We're multiplying 4 by 3, so we're multiplying this by 3 over 3. Notice all the blues are all just really 1, but we're putting it in a form that allows us to have the denominator that we want. I hope I haven't really been messing up all this time. Probably have. All right, hello. It looked like it's back. I did get a notice saying that the sound is gone, so it looks like it's back now. So just let me know. Looks okay. It should be coming. Give it a minute. So just kind of keep updating me every few minutes or so. I see where the two said that the sound is gone, but it looks like it's back now. Can you hear me? Ali Ali Oxenfree? If when the sound comes back, tell me what's the last part of the explanation that you heard, and I can back up. Hello, hello. Let me see. Can you hear me now? Hmm. I still don't know if you can hear me. Oh, okay. Okay, cool. All right. Okay. So yeah, whatever the last thing is that you heard, just let me know and I'll back up to that point. But again, so order of operations, you have this please excuse my dear Aunt Sally's last request. And all that is telling you the order in which to solve these equations in. So first thing we want to do are any parentheses. So we do have parentheses here. So that means we're going to start inside the parentheses first. So the first thing we're going to do is the 3 over 4 times the 7 over 8. Okay. But if we didn't have any parentheses after that, next we would do any exponents. We don't have any of that here. Now the green part with the multiplication and division, if you ever have to decide between multiplying and dividing at the same step, then you just do it left to right. Okay. Sometimes you actually divide before you multiply. So if you ever have to decide between multiplying and dividing, just do it left to right. So whichever order it comes in. Also for addition and subtraction, you just do it left to right. Okay. So now in our example, we do have parentheses, so that means we're going to do the 3 over 4 times 7 over 8 first. Okay. So the original, we have 3 by 4 times 7 over 8 divided by 14 over 15. Okay. So again, order of operations, parentheses first. So now if we say 3 over 4 times 7 over 8, to multiply fractions, we just multiply straight across. Okay, so the top with the top with the top and bottom with the bottom. So this times that, and the 4 times the 8. Nothing seems to cancel, so we'll go ahead and get those numbers. So this is going to be equal to 7 times 3 is 21 over 8 times 4 is 32. And nothing cancels. So now at this point we're done with the parentheses, so we can just drop them at this point because there's nothing else to simplify inside the parentheses. And then we're going to say divided by 14 by 15. Okay. Now when we divide fractions, we use a technique called keep, change, flip. All right. So what we're going to do is say keep, change, and flip. Okay. So then when we divide fractions, that's what we do. So what I mean by that, or what we mean by that, maybe I can move that up. All right. All right. Okay. Hello, hello, Miss Hollis. 1 second. 1 second. Okay. Hello.
Hello?
Yeah.
Yes, I text you back. I can hear you now.
Oh yeah, yeah. I kept going. I think it's just a delay, and by the time I got your response, there's a big gap. But yes, I'm still going. I just started. It's just a
Okay,
delay.
okay.
Yeah. How's it working out for you?
It's going good.
Okay.
It's going good.
Okay. Cool. Yeah. So yeah, like I said, I was just kind of playing around, just seeing, you know, how it works, and so it seems to be working okay. Um,
Yeah.
the whole conversation, the whole thing should be up on YouTube, so it'll be like a catalog, and you can rewind and replay any part as much as you want, as much as needed. So, and then also I can send you a PDF of all the stuff that I'm writing. So
Okay.
you have a copy of all of this, and then you also have the video to go with it.
Yeah, that's good. Okay. Okay.
So yep. Um, but yeah, I'll just keep going. Yeah, I'll just keep going for a while. I still have a bunch of time.
Okay then.
Yep. Okay.
Okay.
See ya. Okay. So, when we divide fractions, we use a technique called keep, change, flip. So what that means is just you keep the first fraction, so it's just going to stay as is. So it's going to stay as 21 over 32. This music Soul Child is one of my favorites. I'm sorry. Hopefully this isn't gonna mess up my thing. They're gonna be like, yeah, music Soul Child. Anyway, all right. So we keep the first one, and then we change division to multiplication, so that becomes multiplication, and then we flip the second one. So the second one is going to become 15 over 14. Okay? So now we could multiply straight across, and essentially that's what we're going to do, the same thing as before. But instead of getting those large numbers, I'm going to expand everything and see if something cancels. Because sometimes when we get those large numbers, it makes it harder to simplify. So what I'm going to do here, 21 is 3 times 7. 3 times 7. 15 is 3 times 5. Right? So that's those two expanded. 32 is 8 times 4. So that's a total of 5 2's. So 1, 2, 3, 4, 5. And then 14 is 2 times 7. 2 times 7. Okay? So now we're going to cancel the like factors. So the 7 cancels the 7. I think that's it. Yeah. So then the final result, that's a 9 and 5. So that's 45 over 1, 2, 3, 4, 5, 6, 64. And you see that result is C. Something like that we can actually check in the calculator, especially if you're using like a graphing calculator. Let me turn it on. Clear. Okay. So in the calculator, what I would do my parentheses, 3 divided by 4. I think this is fine what I'm doing. Times 7 divided by 8, close parentheses. Then I'll say divided by, now I'm going to say parentheses again, 14 over 15. I think you can do that one without it, but I'm just doing something that should work. I'm going to hit math as a fraction. We should get to 45 over 64. We're good to go. Okay? Let's see what's going on here. Okay, so that's good. Yeah, we don't need that anymore. All right. So we got the same result, which is C. And I can get rid of that. Can you hear me now? Verizon propaganda. All right, cool. All right. I am kind of reaching that point of exhaustion, so I probably will stop soon. But let me kind of keep looking. I still feel it a bit, so I'm gonna keep going. But I will stop pretty soon. I think that was all for that one. Let me pull up the messages. So we did that one. We did that one. There was only one answer for part two. We went through all of part one. Did all of that there. We did all of that. Now I could go back to what was handwritten. So I'll kind of pause for the calls. I'll just kind of put out a question. I heard the last question. Okay, I think we answered all of that. So, I kind of want to pause there for a second. I'm gonna give you a call and see if they're just kind of get some feedback real quick. So I have to run it through those explanations. All right, Miss Hollis. Oh, what's going on? All right.
Hello?
Okay. Hello, Miss Hollis.
Yes.
Hi. Okay. So that was just a little overview or rundown of what I had in mind as far as online tutoring.
Okay.
My question for you, I have a few questions for you. Like, I guess, do you feel like you would still need to be in someone's presence, or do you like what kind of feedback could you give as far as that experience?
No, it works. It works. I guess I'm more of a in-person, hands-on, professional student. I mean, I see it,
Mm-hmm.
but I guess it would take some time to get just actually looking at it from, via computer, online, or whatever.
Mm.
But it works.
I see.
I just have to go over information more so on my own and just look at it instead of,
Yeah,
but it works.
I see. Yeah, because essentially, I would do the same thing in person.
Mm-hmm.
Um, because I like general stuff. It's like a bit much. So for me, it's like you just kind of have specific questions, and then I kind of answer the specific questions, and then it's like I'll kind of bring up any topics that come out. But really, in math, that's really what it is. You have to do. You have to like go through question after question. You kind of just have to keep doing it over and over and over and over, like in excess to get it. And it's like most people today, and it's no fault. It's only human. It makes a lot of sense, but it's like that whole thing of the extreme repetition. I don't expect most people to do that, but that's what it takes to kind of get mathematics. And so that's where the discord comes. But you know, but that's what it takes for math. You have to do as much practice, and then it's like, and the only way that the information is going to sink in, it's like you have to kind of be frustrated for a while, and then when you ask your question and I tell you the answer, it'll sink in. You'll be like, oh, I get it now. I actually did a question earlier today. A student sent a question, and I went through what I normally do, and it wasn't making sense. And I sat there for like an hour on this one question, and then I was like, wait a minute, let me look on Google real quick. And I looked on Google, and I saw the discussion. I was like, oh, it makes sense now. Then it clicked, but it's not going to click without me being frustrated. You see what I'm saying? Like I would have looked at it, and I wouldn't know what they were talking about. Um, but but yeah, that's just the nature of mathematics. And I get the whole in person thing, but like take today for instance. It's like we had the ice, in the city, and I'm like, ooh, but I was still able to deliver the whole thing, But I do know that there is some kind of there's something there with being in someone's presence. So it's like I don't know how to capture that sensation digitally, and I don't think you can. But but you know just kind of playing around with some of the different things available. Um, but
I
but
mean, it works.
yeah, but
It
yeah,
works.
but okay. Um, So, and again, you know, like the way we were doing the other day, if you just wanted to snap pictures and I can just make videos on the fly, like this was like this whole live thing was, you know, it's a bit of challenge on my end because I had to have like my computer and internet and power and a lot of different things for it to work. But the pre-recorded videos are actually really easy for me because of whatever update they did on Apple. It's like now you can actually record your screen. So I look at the picture and I just start recording and I just write like normal, no extra equipment or anything. It's really easy.
Okay.
Yeah, like those
Okay.
the pre-recorders are really easy. So that's why it's like I don't mind doing it for free right now. You just send me a picture and I'll just make a video and post it on YouTube and you'll get the link. So those are easy and you can do that anytime and I'll just get to it when I can.
Oh, okay.
Yeah.
Okay. Yeah.
So,
okay. Yeah. 'Cause
you know.
all I need to see someone do is step by step,
Right.
whether in person or online. It doesn't matter.
Right.
Just I need a breakdown.
Yeah.
Of how, of course, how to get it and practice on my own.
And then, like, after you watch the videos, you can still respond and say, okay, when I did it, I did so-and-so, and I don't get this step, and then I can go back and do, like, response videos, or we can, like, talk on the phone or something. But, you know, you just got to have some kind of reference point or something, you know. Anyway,
okay.
You know, I was just playing around with some of the things I'm able to do, and I've been trying to do for a while. So, okay.
Yeah. Okay. Yeah. I sure appreciate it. I'm grasping it. I'm grasping it. I can. Yep. Just gonna go back to the first video.
Yeah.
Chris made as well.
Yeah.
And have my study guide and as far as like the number lines and the grades,
Mm-hmm.
I did the division with the 1 divided into 5 with my calculator, and I need to get that aspect. And some other stuff I do already know previously, but I just need some more.
Yeah.
So
yeah. Again, just the long and short of it all is really just practice. So like if you can just get your hands on examples and just keep working them. Now another thing that you can do with this whole setup that we have, do it yourself, and then again, like I said, snap a picture of the original question and then snap a picture of your work and just send it to me. You can kind of say, hey, could you look at this and give me some, tell me what do you think about this, and then I'll read it over and I can basically walk you through, like, as a grader, what we're looking for, and I could tell you, like, if I were grading this as an official, this is I would take off for this, or yeah, this is good, this is exactly what I'm looking for. Okay, well, you kind of miss this, these kind of things. This is the kind of pointer I would give, and I think that will kind of increase the your learning experience. So it's like, if I can give feedback, as opposed to it being one-sided. So
okay, yeah,
it's just some ideas. So okay. That was really nice. I really appreciate you that. I honor you for that. That was really nice. I know it wasn't simple, but it's just I couldn't not try. I had to try and see what happens. So
yeah.
So
okay, yeah. So I will just whatever I come up with, I'm free to send you.
Yeah. Just keep snapping pictures, and now if I'm out, I won't be able to respond right away. But usually when I get back in, I'll just look at it and I'll just start recording my screen and say, hey, okay, I see what you have. This is the original. Okay, I see what you were doing. Okay, you drew a picture. It looks good. It makes sense. Okay, you started at the right point. Okay. Well, you missed this. And that's the kind of stuff that I'll do based on what you send me.
Okay. Yep. Okay. Because I'm really having problems with those variables.
Oh. Yeah. So again, like the best thing there is an example, because like variables, all it is. So variables as a kind of starting point. So algebra is nothing but arithmetic. Arithmetic is nothing but addition, subtraction, multiplication, and division, right? So we do have to know like the timetables and all that kind of stuff, but that's the starting point. But now algebra, the only difference between arithmetic and algebra, you'll do things like you'll have some part that you don't know. So in mathematics, when there's something that we don't know, we just give it a name and then proceed like we normally would. So like if I know I have 12 pieces of fruit, and if I have 12 pieces of fruit and only 2 types, and one type is apples, and I have 5 apples, so then how many oranges. So I would say 5 plus the unknown, which is I'll call it O, equals 12. Then I would just say, you would subtract. We have some ways of going about that, but that's the gist of it. It's like you would still use arithmetic like before, but you just have ways around those variables. You know.
Yeah.
So, but it'll come again. The best teacher is just going to be experienced. You just got to get in there, and you have to just work questions. And I struggle with it myself. I mean, I'm still in school. I'm still working on my doctorate. I'm not like in a school right now, but I still study. And you just kind of got to keep practicing until it clicks. It's really just hard. It's really just hard work. That's all it is. I mean, but that's just and hard work. I know those are like opposite energies. You know, you can't really say it's just hard work because that's a mouthful. But yeah, I will end it there. Okay.
Okay.
And thank you again, and I'm here. Okay.
Okay, thank you so much. I'm gonna go back on and just look at the sessions and stuff and just do a little studying. But yeah, I appreciate it. And I'll be in touch.
Okay, my pleasure. Thank you again.
I appreciate it.
And from one beautiful mind to another, enjoy the rest of your day.
Okay, you too. Thank you.
Thanks. Bye. All right, so it was a pleasure. Again, from one beautiful mind to another, you all enjoy the rest of your day. Take care.